Good day, all, and thank you for joining us today for the Getting to Know and Use CTDL webinar. We truly appreciate all of you taking the time today. We're going to start off with this webinar with all of you muted, just so we don't get background noises. We are recording, and the recording will be available to anyone who would like to view it after the webinar. We'll put it on our YouTube channel, so no worries about getting the archive webinar afterwards. For those of you who may not be familiar with Credential Engine, we are a nonprofit, and we have a big and important mission for credential transparency. And we do that to empower people. So it was apropos that Phil was talking about empowering people at the beginning of this webinar. And our vision is to map the landscape of credentials. And we do that through a number of programs at Credential Engine, and we do that through technologies and infrastructure. And today we're going to be focused on one of the infrastructure solutions offered by Credential Engine, and that's the Credential Transparency Description Language. So thank you for joining, and we can go to the next slide. This webinar is a follow-on to our kickoff of the CTDL advisory group that occurred on February 14th of this year, where we provided an introduction to the CTDL, and we asked participants with that advisory group if they would like a deeper dive. So this is a follow-on to this. So we will provide you a link to that introduction. So if this is new to you, you can also watch that introduction to kind of help get into the deeper dive that we are covering today. You will have two CTDL experts presenting today. Phil Barker and Nate Argo have been working on the CTDL for quite a while now, a number of years. They are experts on the CTDL, so you are in great hands in that deep dive today. So we're going to talk about some of the resources that are open to anyone to use, including the CTDL Handbook. And we're going to dig a little bit deeper and answer some questions like, well, what is RDF? What is linked data? And some examples of using CTDL, of course, because the purpose of the CTDL is for anyone to use it. And we can go on to the next slide. There's supposed to be an image there. I don't know why it's not displaying. But just as a reminder, the Credential Transparency Description Language consists of three schemas: the CTDL, which is all about credentials and things adjacent to credentials, including jobs, occupations, tasks, work roles; CTDL ASN, which is all about competency data; and quantitative data that for Credential Engine is about aggregate outcome data. As a reminder, with the CTDL, we don't talk about personally identifiable information, nor do we put personally identifiable information in the credential registry. And we can go ahead and go on to the next slide. And I would like to go ahead and turn it over to our presenters. There is going to be two sections in the presentation. We'll pause after each section for Q&A. If you have questions during the presentation or comments, you can go ahead and use the chat at any time, and we'll also address things in the chat. And then folks can unmute during the Q&A periods. So thanks again for joining, and I'm going to turn it over to Nate Argo. Take it away, Nate.
Okay. So we wanted to go over the CTDL Handbook, or maybe more appropriately, the sort of all schemas handbook, as we sometimes call it, because the idea is that we wanted a resource we could provide to essentially everyone that we talk to that goes over all of our schemas, that describes how to use them, when to use them, where to use them, provide some use cases and examples and things. So that's kind of a broad overview of what the handbook is. And that's linked at the bottom of this slide. Go to the next slide, please. So if you were to go and look through the handbook, you'd see that it's made up of a number of sections. Each section of the CTDL Handbook has a link in the table of contents, which is an expandable, collapsible menu over on the left side of the page. Next slide, please. And then at the top of the handbook is an introduction section covering a bunch of frequently used terms, covering some background info for things like RDF and linked data. Not everyone's familiar with those. And then at the bottom of the handbook are a number of references to things that come up in the handbook in several different places. Next slide, please. And then the majority of the content of the handbook, those sections I mentioned earlier, go over individual classes or sets of classes in CTDL. They show how they're used, why they exist, how you accommodate certain use cases by using those classes and properties. And those generally consist of what we're looking at here. You'll have the header, an introductory text section that kind of goes over what you need to know about it, and then one or more examples with a visual. You can see that on the lower left here. And then accompanying that visual is a list of the classes and properties over on the right, along with JSON LD and RDF turtle representations of what you're seeing in the example itself. Obviously, we can't click on it here. It's an image, but if you were to click on it, you would see essentially a block of JSON showing here's the credential class, here's the credential class linking to all these other things that are in that example. Next slide, please. So I mentioned that it covers all our schemas. So here we have just a quick screenshot of what those sections start to look like. The CTDL is by far the largest section with the most information in it here. This slide also provides links to CTDL, CTDL-SN, and QData sections for the handbook. They're all in one handbook. We did originally at one point have separate handbooks for each of them, but we combined it because it made certain things much easier to discuss, particularly whenever a certain use case requires terms from 2 or more of those schemas. Next slide, please. So toward the bottom of the handbook, we also have some more detailed examples that get into very specific use cases where there's subtle differences in how you might cover something. So the ones throughout the majority of the handbook are more high level, more general, more broadly applicable, but there are occasionally things we either see a lot or we've seen very niche cases or just anything else that requires more detail to its examples. We have a whole section for that towards the bottom of the handbook. Next slide, please. We also wanted to, and I believe we mentioned this in our first meeting, but we wanted to also mention that, everything that we have on the CredReg site in our schemas and our handbooks and so on, it's openly available. Anyone can use it. It's openly licensed. We have the technical site there that's linked. It has not only the handbook, but also the terms pages, serializations pages is where you can see JSON LD representations of the entire schema. We have the mapping guidance that we'll touch on a little bit in a later slide, and as well as release histories for the entire schema, so you can kind of go back in time and see at what point we added various things to the schemas, as well as policy pages for updates and namespace related things, and then links out to our GitHub repository where you can participate if you are so inclined, but also it's where we keep track of the decisions and the sort of processes we take to update the CTDL via GitHub's issues feature. Any questions on any of that? Sorry, Phil, were you going to say something?
No, I was just going to ask if there were any questions.
Yeah, Nate, tell us about who the type of audience the handbook is geared towards.
So the handbook, we tried to write it to apply to a general enough audience that we can show it to basically anyone that we work with. There are some technical details to it, especially in the more detailed example sections, but you don't have to be, sort of very technically minded, very RDF minded to get it, quote unquote. We did try to write it, generally enough that anyone should be able to pick it up and kind of get a sense of how CTDL works and how they would use it.
Great, thank you, Nate. Now is the time. If you have questions, go ahead, raise your hand, put them in the chat. Any questions about the CTDL handbook? Let's see.
I think if there are none, we can move on to.
Great, thanks, Tom.
Which.
Yep.
So what I want to cover in this next section, you've probably heard that CTDL is based on RDF, or that we provide linked data. And if you haven't heard linked data, you might have heard of JSON LD, where the LD stands for linked data. What I want to do in this section is to explain what we mean when we say those things, and how does RDF work, and how do we build up descriptions using RDF. If you're interested in going more deeply into this and into the history of RDF, the semantic web and linked data, there's a very useful publication that came out 2021, which was looking back at 20 years of RDF. RDF is a W3C recommendation. It stands for Resource Description Framework. And here resource means anything, whether it's concrete, digital, or conceptual, real or imaginary, anything that can be identified. The standards were developed by W3C, the World Wide Web Consortium, which is the body that oversees development of standards for the World Wide Web. And work on the standards started around the turn of the century. The focus of work on RDF has changed over the years. Initially, the focus was on the semantic web, as it was then called, which was supporting one approach to artificial intelligence with knowledge representation, and a web that allowed logical inferencing based on meaning rather than just links between text and data documents. Then the focus shifted somewhat to linked data, which has more of an emphasis on interoperability and on sharing data, and that's a focus that we very much have. And then the focus shifted again slightly to large-scale knowledge graphs, large-scale representations of large amounts of knowledge or data that's linked together. And as such, that underpins many products from tech giants like Google, Amazon, Netflix, and very smaller private knowledge graphs, but also large open knowledge graphs like Wikidata, DBpedia, that anybody can access. But the important thing to bear in mind is that really semantic web, linked data, knowledge graphs are just different terms for what you can do with RDF. So let's look at what RDF is in more detail. The basis of RDF is a statement, which has three parts: a subject, a predicate, and an object. And as such, it is very like a simple sentence in English. So here, what we are saying is that some training organization offers a certificate in cybersecurity. So the training organization is the subject, the certificate is the object, and the predicate is offers. That's, it reads like a sentence in sort of natural English. It's important that each statement stands independently on its own terms. It's not part of a record, and it draws no meaning from the context within which it's made. So, there's nothing else that's said about this subject that affects the meaning of this predicate. And that's important when it comes to combining predicates that come from different languages, and I'll build on that later. Everything in RDF is identified with a URI. So here I've got the code for what's said in this example here. And because you identify everything with a URI, you can look it up using a computer, and I'll build on what that means later. And that essentially is it as far as RDF is concerned. Yes, there's 20 years worth of sophistication that's built on top of that, but this is the core of how RDF works. And there's a quote here from Dan Brickley and Libby Miller that people think RDF is a pain because it's complicated. The truth is even worse. RDF is painfully simplistic, but it allows you to work with real-world data and problems that are horribly complicated. So let's get a little bit into that horrible complexity. The meanings of the terms in RDF statements are defined in what we call vocabularies, and CTDL is one such vocabulary, or family of three vocabularies, if you prefer. Terms can be properties or classes. So, the items within the language can be either properties or classes. Properties are used to express relationships or characteristics of a thing being described. They're what turn up in the statements as the predicates. Classes are used to classify the type of thing that an entity is. So here we're saying that this type of thing is a credential organization. We also have concept schemes that are used to provide controlled values, value lists for some of the properties. And I won't go into that very much today, but it's useful to know that they exist. Because everything is identified with a URI, including the properties, if you were to follow that URI in the statement that I gave previously, you would find a definition of what the property used means, which looks something like this. What's also interesting, you can do the same for classes. Here's the definition of the credential organization class. What's also important is that terms are defined in RDF. Because the data and the term definition are both in RDF, applications can query both the data about the credential or the data about the organization and the data about the terms that are used. And here, shown quite subtly, is the fact that CE terms credential organization, in the definition of what that term means, says that it's a subclass of organization. And if you were to look at the definition of CE terms organization, you'd find that it's equivalent to schema organization. So what this is telling you semantically is that when we classify something as a credential organization using CTDL, it is possible to infer that it is also an organization according to this other language, which is from schema.org, the schema organization. So that's the bit of RDF that allows you to do semantics, allows you to do logical reasoning based on the definitions that are provided of the classes and the terms that you are using when you're describing something. So you can have an entity can be a subject or an object of many statements, and this builds up rather than just a simple, item to item with one link, a network of items that are linked together, each item being described. And the network of resource descriptions that we have here is called a graph. That's just the mathematical term for this type of diagram. Since the data in it also includes links to the term definitions that are being used, it's also, and that can be used for inferencing, it's also called a knowledge graph because it represents the knowledge on the information that we have about these entities represented here and how they are related to each other. So this particular knowledge graph shows that there's a credential organization that offers a certificate. In order to gain that certificate, you're required to have two competencies. The competencies are described in text. The same organization as offers the certificate also offers a course, which is preparation for that certificate and which teaches those two competencies. The address of the credential organization is provided and the course is available at that address. This is as much as I can fit into one diagram, but it still shows, so I could provide a lot more data. I could go on to show other courses and other credentials that are related, for example, part of the same program, or stackable to add up to more substantial credentials, or with pathways to recommend a sequence in which those different courses and credentials could be taken or earned. And we could show how the credentials and competencies are linked to occupations, and how the employment prospects for a holder of the credential, what are the employment prospects for a holder of the credential, or we could show the accreditation details of the organization and the course, and so on. And it's that level of depth of detail that we mean by transparency when we call the CTDL the Credential Description Transparency Language. Transparency can be provided in data for any credential that's being offered. Even this small graph here gives you the data that you need if you have a question. Where can I go to earn a certificate that shows that I have these two competencies that I know are necessary for a job? So I mentioned earlier that everything's identified with a URI, and the URIs can be followed as links to more data. So we're getting into linked data here. If we just look at this part of that knowledge graph that I was looking at earlier, the competency with the competency text, on its own, that's maybe not enough information for you to know exactly what it means, but it's identified with a URI, and I can follow that URI, and it happens to get some data from the, in this case, the Credential Engine registry, fairly technical data. You can see the text here. Not much information is added apart from the fact that it's got a coded notation here. But what's really important is that you can see that it's part of something else. And if you follow the link for something else, so linked data links to linked data, you get much more information about the competency framework that competency is from. And you can see that it's drawn from the NICE cybersecurity workforce framework and its abilities, and you get a description of that. You get all of the other competencies that are in that framework, and you get information about what it's relevant to. So that's what we mean by linked data. That's what we mean by providing more information about anything that's referenced in the data graph. And this is important because, just as there's a limit to what I can fit into any one diagram, there's also a limit to how much data I would want to send in response to any one query. But what's important is that the data that I send in response to a query, or the data that I include in some other representation of a credential, includes the links to all of the data that's held in the registry or elsewhere. It doesn't have to be data that's held in the Credential Engine registry. It could be data that's held in the held by the publishers of the course or of the competency that you're talking about. Okay. Mixing and matching between different vocabularies. I've covered so far what can be said using CTDL, but CTDL doesn't cover everything. For example, as Jeannie said earlier, that there's very little that relates to PII in CTDL, and of course, other organizations will have the vocabulary that they want to use. The important thing is that RDF allows you to include terms from different vocabularies, often indicated by different namespace prefixes. So here we've got CE terms as a namespace prefix. You can do this, as I said earlier, because of the way that RDF is built up of individual atomic statements, where a statement doesn't depend on other statements for its meaning. So nothing about the term that you use in a statement requires there to be some other information provided in order for it to be it's not dependent on any other statement. So let me take you through this example. Statements 1 to 5 repeat the example of an organization offering a course that teaches a competency. So this identifier here is an organization. It offers something that's got this identifier. And that identifier, the one that ends in 56F, is a course. That course teaches something, and the thing that it teaches is a competency. Note how statements 1 to 4 use terms from our CE terms vocabulary, and statement 5 uses a term from the CE ASN vocabulary. So these are all CE terms, vocabularies, the properties and the classes, but here you've got a class that's drawn from a different vocabulary. It's another one that's maintained by Credential Engine, but it's the Credential Engine's profile of the achievement standard network, which is used for describing competencies. Statement 6 is from our definition of teachers. So this is where you're getting the data from the definition of the terms that we use. And we define teachers as being equivalent to schema.org teachers. Note how that one statement uses 3 different namespaces, 3 different vocabularies: CE terms, OWL, which is the web ontology language, and SDO, which is schema.org. Statement 6 allows us to rephrase statement 4 as saying that this thing here teaches, but using the schema.org version of teaches, this competency here. And that puts us into the world of schema.org. And schema.org is used web-wide to describe pretty much anything that you could find on a web page. And one of the things that you can find on web pages are job postings. So we can imagine that elsewhere, somewhere on the web, is a job posting here. And that job posting uses the schema.org language, SDO skill, to say that it requires among its skills this competence here, which is the same one that we're saying our course teaches. So that is a trip in code from the example that I gave previously here to a reference from a job advert that needs the same competency. And I hope that it gives you some ideas, even if you haven't followed all of the details, gives you some ideas of how the RDF approach can be so powerful in linking between data that comes from completely different sources, that uses different languages and uses different data sources. So I stop here for any questions. I can see one. Oh, sorry. Yes, PII is personally identifiable information.
We do have a couple of questions, Phil,
I'm not
that
surprised.
came in the chat earlier, and this is a time where I would encourage folks to raise your hand so we can unmute you. If you would like to verbalize a question, we welcome you to do so, so please feel free. One of the questions that Robert had has to do with using a relational database versus, you know, a triple store or another data store like the registry that actually stores the raw JSON LD. And this might be something that Nate can pitch in as well, but how those two can, you know, find parity, how they can work together, because a lot of people aren't really all that familiar with RDF, but as Nate was pointing out earlier in the handbook, once you start to look at it, you actually, and you, Phil, were pointing out it's pretty simplistic. So it's I think people find out it's not as hard to understand, you know, once they dig into it. But let's talk a little bit about that question. And then the other question that came from Don present was the distinction between ASN and CTDL. Okay.
I'll cover the first one. Sorry, the second one first, because it's an easier one to cover. ASN stands for Achievement Standards Network. They produced a language for describing competencies, competency frameworks, and rubrics. Credential Engine have modified that, built on it to create the language CE ASN, which is technically speaking a profile of ASN. It's it's focused very much on competencies. CTDL, talking about the CTDL core, covers credentials on its own, and the things that are related to it, such as the organizations that offer credentials, the courses, the assessments, occupations that might require a credential. We use the two together seamlessly so that it's most description, I dare to say most descriptions of a credential will include some CE ASN in there, but they're just two different vocabularies that have two different specializations. Relational databases versus or relational databases for RDF or compared to triple stores is quite a big topic. It's possible, it's not entirely difficult to export data from a relational database as RDF. That's the way that most RDF, I think, is generated, especially from schema.org. Schema.org was created in order to facilitate that sort of export.
I think the original question was, is it safe to say there is parity between this model and something that might be more familiar like a relational database? And I commented that they're similar notions, but the mechanics of it are different, because in both cases you've got, here's a series of objects. These objects have properties that describe them, and these objects connect to each other in some set of ways. And that's where there is parity, but the mechanics of how all of that works and what's practical for RDF versus what's practical for a relational database are very different. And finding the right balance of those things is where implementing this can be that big topic.
And there are some things that are built into triple stores that are oriented towards RDF that come pretty much as standard. Things like influencing, things like knowing that if you know that one property is the inverse of another, then a triple store, if you set it up in the, with the right options, will do that automatically. If you know that one property is equivalent of another, then the triple store won't mind which one you use when you're querying. It would be a lot of work to program that into a relational database. So anything that you could express in a relational database could be expressed in RDF. There are some things that RDF does more easily, some things that relational databases do more easily. Right. Does that address the question? I see this.
So I guess I'll just elaborate on the question. So I'm always thinking about ways that I can go and teach other people about this, right? So from my company's perspective, I work with clients pretty frequently on various elements of what I call the skills continuum, which are the 5 requisite technologies to pull together a meaningful micro-credential system. So the micro-credentials, pathways, skills. And then on the far side of the spectrum are things like the rich skill descriptors. So when I'm trying to describe the value, the utility, and how you can engage with those sorts of things, sometimes using something that someone might already understand, like a relational database. A lot of people work in Excel and Google Sheets and these sorts of things. Spreadsheets are very familiar to people. So it was really helpful for you to explain where there's sort of bifurcation and the difference between relational databases and RDF. And I'm just going to look into that more, but thank you for elaborating.
Well, one thing that I will say, since you mentioned spreadsheets, RDF is based on triples. With a spreadsheet, you have a row, a column, and the cell that you put your entry in. So that's one way of representing a triple.
Right.
And there are technologies that are based around extracting RDF from those triples. Where things get a little bit difficult is when you want to provide more than one entry for row and column. Putting more than one entry into a cell.
And kind of
thanks, guys.
Related to that, we had a question from Don. Pros and cons of RDB versus graph databases. Is the former more mature but less flexible? I think it depends a lot on the use case of what problem you're trying to tackle, as to which one you would kind of go with. There's also, document-based databases. There's graph databases, which are slightly different from triple stores. They cover kind of the same ground, just with different ways of approaching it. So it's a lot of the same kind of questions that go into really any kind of software development. Is what is the right tool for the job, and that just depends on what the job is.
Yeah, and a couple of examples on that. Triple-based and graph-based data stores can be quite slow in responding to queries, but they are very good at being able to answer questions that you hadn't thought of when you put the data in. Some people class RDF databases along with schema-free or no SQL, or not only SQL databases. So, it can be more flexible than a relational database schema.
Then we had another question. How are RDFs created? Is it an automated process? And I don't know if that one got answered or not. I'm looking through the chat here.
Well, you can sit down and I sat down and write all of these. Sat down and wrote all these by hand, but nobody's going to do that at scale. There are plugins that allow you to export data from relational databases as RDF. I think that's probably one of the most common ways of creating RDF.
And for Credential Engine, you're really talking about the data that becomes expressed based on RDF. So that would be for us in the registry, that's JSON LD, and that is all automated. So regardless of the tool that you would use with Credential Engine, if you want to take information and convert it into the CTDL linked data structure, then whether you begin with a spreadsheet, for example, or a manual entry, it will all go through the Publishing Assistant API, and it will come out as that CTDL linked data structure. So nobody is manually, writing that data. That is all automated.
Yeah.
Going back to the question about the ASN versus CTDL, did that get answered? The different schemas and how they integrate?
I tried to answer it, yes.
Oh, okay. Okay, good.
We had one more question. This may be a very basic and obvious question, but is there any built-in data integrity verification or of accuracy for what's put into the database?
Mm-hmm.
I guess that depends which database. If you're talking about the Credential Engine registry, then the answer is definitely yes.
Yes, with the credential registry, that API that I mentioned, actually the technical site that Nate introduced at the beginning of the webinar has an entire section on the credential registry. And it has a handbook about the API, the Registry Assistant Publishing API. And that API plays a role in looking for, the right valid data formats and so forth, and making sure that the data is always formatted correctly. So you have that dependability of the data in the registry, knowing what every CTDL term means, because every CTDL term is defined, and you're going to have that consistent data quality check. We also have a number of currency policies, but if you are using CTDL in your own environments, then you would, of course, put your own quality, guardrails in place.
And one of the things that we shall be working on over the next year or so is an RDF way of expressing those data requirements, which is called Shackle, Shapes Constraint Language, that stands for. So that's a way that you can define your own data requirements, and there are tools that will allow you to, once you've defined the data requirements, they'll allow you to check whether a particular data set meets those requirements or not.
Yeah, and just to answer that one a little bit more broadly, that kind of goes back to what Phil had mentioned earlier about the different types of databases having different feature sets. You know, in a relational database, you can use constraints and things to enforce, you know, this is a required field, this must connect to that, there must be, you know, a reference to the primary key on this other table, stuff like that. Whereas in a triple store, let's say, I think you could say there's only 3 fields and they're all required. It's just that subject, predicate, and object. So it's a different set of mechanics for tackling the same issue.
Yeah,
Gives you more flexibility, but also that flexibility makes it easier to be wrong sometimes if you put something wrong in there. So
even in a triple store, though, you can say, you know, you must have some statements with this as the subject,
yeah.
Or, you know, if this is the property, then the object must be of this type.
Yeah.
Yeah.
So again, right tool for the job, depends on what the job is.
Mm-hmm.
I think we answered all the questions so
There
far in
was
chat.
actually a follow-up to what we just answered.
Mm.
I was not just thinking of formatting, but wondering about checking if the information was truthful in terms of accuracy. Oh, okay. Or does it depend on the integrity of the humans entering the information? So I assume you're talking about the registry in that case.
Yes, they would be.
Okay, so just to kind of go over that one real quick, the data in the registry comes directly from the actual like sources of the data. We work with, you know, the states and the institutions and things. They either publish that themselves or they work with someone that they authorize to publish that. We do not go out and like scrape the web for that information. So it's accurate according to the people that host it, I suppose.
And that's probably a good cue to move on to the next section, Nate, which is you talking about, well, we'll be covering a couple of examples of using CTDL, but first of all, it's you talking about CTDL in the registry, isn't it?
I believe so, yeah. So this slide here, I just wanted to summarize or I guess remind everyone that you know, anyone can use CTDL with their data, with the way that they integrate their systems together, with the output that they use, whether that's in like an export or whether that's in the meta tags for a web page that search crawlers can read. If you're developing a new system, a new database, a new data model, we encourage you to take a look at how RDF works and say, hey, maybe there's something we can take from how this thing works and apply it. If you're doing a system that is specifically credential related, you know, we also encourage you to take a look at CTDL specifically and say, hey, are there classes and properties and sort of relationships in the way that all this stuff works that we can apply in what we're building. So you can use, you know, our schema in your system, even if you're not directly using the registry. And just kind of, we have a few examples of things that are using CTDL and may or may not be using the registry, I think, depending on the example. So the first one here, and this actually is a lot of what we just covered. So we have a series of what we call mapping pages on the CredReg site, and those take the CTDL, they present it in kind of an object-oriented way. You can see, and well, maybe you can't depending on your screen size, the menu on the left side of this page has a list of the classes. And then if you were to click on any of those classes, you're going to see here's all the properties for that class. So it's the same schema. It's just being presented as if it were something you would find in a more object-oriented context here. And then we've got pages for CTDL, CTDL ASN, and QData that all show those the same way. And it's not in the screenshot here, but at the top of each of those pages, there is an option to see either the entire schema in that way, or you can see just the subset of the schema that's used in the registry, because there are a few things in CTDL that are not used in the registry, but are more there to enable connecting to other languages, other schemas and things. So going back to the idea of showing some examples, we have a couple here. One is the Credential Finder, which is a website that Credential Engine hosts, maintains, and runs. The purpose of the Finder is to show all of the data that's in the registry. And that's not just the individual resources, but also all of the properties and things on those resources. So you'll see we have a search, we have detail pages for just about everything in there. On those detail pages, you'll see here's every bit of data that we have in the registry about this thing. Those detail pages largely pull from the individual record for whatever the thing happens to be. So like the credential will show you everything that's in the credential, but it will also, depending on what that thing is, go out and fetch some data from the related records. So you'll see here's the credential and here's some information about the organization that offers it. Here's some information about the assessments it requires, the competencies that it requires, and so on those pages. But all of that data comes ultimately from the registry and is encoded using CTDL, and the finder exists to kind of show that off. Here's what you can do with it if you were to go out and build kind of your own finder, and take the subsets of this that are relevant to your audience, to your customers. Here's the kinds of things you could do with not only the CTDL but also with the registry. Next slide, please. And the Indiana Career Explorer is another example of a website that kind of did what I just said. They went out and built their own search that pulls in data from the registry using, again, our schema, obviously, and then presents that in a way that makes sense to their customer base, to their users. And I don't know if anyone wanted to expand on that or not. We actually just pause for questions here too. Before we move on.
I think actually, Nate, we've got 10 minutes to go, so I want to crack on with the next part. And what I want to talk about is using CTDL and referencing data, which in this case happens to come from the Credential Engine registry, but could come from any other similar data store, about using those in something that's got nothing to do with Credential Engine. It's W3C's, World Wide Web Consortium's Verifiable Credentials standard. This is another standard from the body that sets the standards for the webs, that deals with credentials. Slightly confusingly, they have a slightly different meaning for credential in two different ways, in fact. First of all, they're not just talking about educational or occupational credentials. They're talking about anything that makes a statement about an individual. So driver's licenses, university degrees, government-issued passports, identity cards, whatever. And it provides a standard way to express those credentials on the web in a way that's cryptographically secure, privacy respecting, and machine verifiable. And I'm not going to go into too much detail about what that means, except that the thing to bear in mind is that they are tamper evident. What's in there might not be truthful or accurate, whether you trust, but what you do know is that it hasn't been changed since it's been issued, or you can at least see whether it's been changed since it's been issued. And so if you trust the person who issued it, then you have a degree of trust over what's stated within the verifiable credential. The structure is really simple. There's a graph which says what type of credential is being represented. Who issued it, which is the issuer, example university, when it was issued, and a link to a individual or the identifier for an individual and what they claim. In this case, they are claiming to be an alumni of example university, and the credential is issued by example university. So assuming that you know that, assuming that you trust example university to know who they taught, who was enrolled with them, you can trust this claim, and you know that it hasn't been changed because of the bit that I haven't shown down at the bottom here, which is the proof, which is a set of cryptography that allows you to see whether it's been changed since it was issued. W3C Verifiable Credentials are the basis for several new and emerging standards. For example, OneEdTech's Open Badge version 3 and Comprehensive Learner Record version 2. They can be used in HR Open's upcoming Learner and Employment Record Resume standard, and they will be part of the Europass European Learning Model version 3. Not to mention a whole load of non-education adoption, because remember, these aren't limited to educational qualifications. Note how this provides a way of linking to things it's a way of linking individuals to things that they might claim to have: skills, course attendance, assessments passed, degrees. And that's exactly the type of personally identifiable information that CTDL doesn't cover. So CTDL and W3C Verifiable Credentials are very complementary. They each cover the thing that the other doesn't, and they do so in a way that means that they can be used together. And what I'm going to hopefully show you quickly is how they can be used together. Here is an example of code that comes from the W3C standard. And the bit that we're interested in is this bit here, which asserts that, you know, somebody has a degree, a bachelor degree, which is a Bachelor of Science and Arts. That doesn't give you a great deal of transparency. You know, you know who issued it, this example university again. You know, it's a bachelor degree, whatever they mean by that. You know that it's a Bachelor of Science and Arts, whatever that means. You don't know anything about, you know, what skills are being credentialed here. CTDL can add the information about what the degree or, you know, the particular credential actually means, with a little bit of help from Open Badge version 3.0. And the way it works is a bit like this. You'll recognize, hopefully, this previous graph, and we can slot it in to the verifiable credential so that our credentialing organization becomes the issuer, and the certificate becomes the thing that the individual who owns this credential claims to have. And fortunately, doing that in code is a lot more elegant than trying to do it by mushing two graphics together. And in code, it looks like this. So you've got the credential subject who's identified here using an identifier scheme that comes from W3C. They have an achievement that comes from Open Badges 3.0. Notice how we're mixing and matching different vocabularies. We've got one from W3C Verifiable Credential here, one from IMS, or one EdTech rather here. And here we're saying that this type of achievement is a certificate. We're using CTDL, CE terms there. And we give an identifier for that, as well as the name, Certificate in Cybersecurity, and we say what it requires. These IDs are URIs. You can follow them. So you can follow that link to get all of the rest of the data about that that credential that the person is, or that certificate rather, that the person is claiming to have. Likewise, you can follow the links to the, well, we've already followed this one, it's the link to the competency. And remember how there's all of the links from here to information about the organization that came up with this competency, and, you know, where it sits within a framework of other similar competencies. So this is an example of how just a few lines of code inside the verifiable credential that came from somebody else, a few lines of CTDL code can include information that expands and provides transparency behind the credential that was issued. And an example of something similar comes from Digital Promise, who are issuing similar credentials. They're not actually using W3C's verifiable credential, but they're using a similar mechanism. And they are including in the credentials that they issue links to information that comes from the Credential Engine registry. And they are using properties within their, you know, the code representation of this credential in order to represent that information. Another example from Parchment, showing a diploma. Again, all of this information here, the program details, the program link, more detail at Credential Finder, that's all CTDL. That's all data that's coming from the registry. So we have a little bit left. We have little bit of time left for questions and discussion. I want to leave you with some questions to think about, but while you're looking at that, are there any questions from the chat that didn't get addressed?
Phil, some questions did come in the chat. We've been answering them
Thank you.
in the chat. So if anyone feels they would like more information about the question you put in the chat, let us know, raise your hand, or if anybody wants to go ahead and raise your hand and unmute now. This would be a great time to ask more, general questions on using the CTDL in particular. And we're not seeing any hands raised or talk more about front end tools. We got a request, talk more about front end tools.
Looks like we have a new question from Noah in the chat.
Yeah, we also have one from Don, a request to talk more about front end tools. Don, probably need to hear more from you about what you would want to hear about that.
My question is related to Noah's, really. It's CTDL for the rest of us. If those of us who, it's a rich language, it's I would call it almost like a back-end technology. And so what I see the power of it. The power is hard to engage with. And so just talking about front-end tools, ways of engaging with this and maybe starting to do something in a small way and then building on that over time. I think it's a bit of a cliff for people, and I hope I'm reflecting Noah's remarks with that.
I'm really pleased that you can see the power behind it, because that was what I certainly aimed to address. And you're right, there are front-end tools that help you engage with it. And one of the key technologies that helps with that is JSON LD. Most developers will know JSON, JavaScript object notation. It's core to web APIs all over the world. And a little modification to JSON can give you a thing called JSON LD, which links the JSON documents to RDF statements. So that's the ramp up the cliff that has been really effective over the last 10 years or so.
So that's good for developers. I guess my question is, the rest of us who aren't developers, certainly we can call her a developer and drag them in and say, this is important, we need to do this. But for the rest of us, say, coming up with our own competency frameworks and getting them in there, we're looking for them to align credentials we might have, aligned to things that are in there, that kind of stuff.
I think we can probably address that in future sessions.
Yeah, it's a great suggestion.
We're not going to do it today.
Great setup, Don. Yeah, definitely we can, there's a lot to talk about, there's a lot to explore. And so, certainly we can cover additional topics in more depth that build off of this webinar. We are
we're at time. We've got comments coming in the chat, which give some of the information about some of the tools that Credential Engine have provided. We always send out further information after these calls. I'm doing Jeannie's bit now, I think. And that information will include links to all of the resources that you see on this screen here, and it will include the contacts for the team who can answer any questions that come up in the future.
Yes, thanks again to all of you for joining today. We truly appreciate you, and we're looking forward to continuing to work with you in using the CTDL. Have a great day.
Thank you all.